Section 6.3 deals with angles and radian measure. An angle is two rays with a common endpoint called a vertex. The terminal side is fixed. The terminal side rotates. So this would have rotated up to cause my angle theta. We can have positive angles and negative angles. When we put the initial side on the positive x-axis on a coordinate plane and rotate the terminal side counterclockwise, we have a positive angle. And when the initial side is on the positive x-axis and we rotate clockwise, we create a negative angle. Angles can be measured in degrees or radians. Radian measure can be thought of as an arc length by a central angle with a radius of 1. So here's my circle, radius 1, I have a central angle. This is radian measure. What is the circumference of a circle with a radius of 1? Well, circumference is 2 pi r, and if r is equal to 1, then the circumference is 2 pi. So therefore, we have 2 pi radians going around my circle. If I went around that circle in degrees, I would, starting on the positive x-axis, I went 360 degrees. To convert from degrees to radians, we know that there are 2 pi radians in every 360 degrees. So I'm going to multiply my degrees by 2 pi over 360, or usually we reduce that to pi over 180. That belongs here. If I go from radians to degrees, I multiply my radians by 180 degrees over pi radians. Let's do some examples. We want to convert from radians to degrees. If I multiply this by 180 over pi, the way I remember that it's 180 over pi is this way, but the pi's cross out, and I'm left with just degrees. So I have 180 over 9, which is 20 degrees. Again, from radians to degrees, you multiply by 180 over pi, the pi's cross out, and then you reduce your fraction and get 108 degrees. One more time, 180 times pi, these cross out, 5 times 180 is 900 degrees. If I want to convert the other way from 150 degrees into radians, I'm going to multiply by pi over 180. I remember that because 180 is degrees, my units cross out and I'm left with radians. When you reduce that fraction, you end up with 5 pi over 6. Multiply by pi over 180, your degrees cross out, you're left with 11 pi over 6. 540 times pi over 180 equals 3 pi. You'll notice my answers have the pi in them. They're exact, and that's how most of our answers for radian angles will be. Coterminal angles are formed by different rotations of the terminal side, but when we're done, the initial side and the terminal side are in the same spot. For example, if I have my initial side here, it's fixed along the positive x-axis, rotate in a counterclockwise to 45 degrees, there's my 45 degree angle. On this one, if I have in my initial side on the positive x-axis, I rotate clockwise to the same spot, that's negative 345 degrees because I went clockwise direction. If I put that on this side over here and rotate around, there it is. They end up on top of each other. An example of this says find 3 angles that are coterminal with 30 degrees. I like to draw the picture. So here's 30 degrees. Yeah, it's probably down here. Okay, I can add 360 to it. So I'd have 30 plus 360 and you end up with 390 degrees. That's coterminal. They end up in the same spot. I could go the other way around. Switch to red. And I go from here and go backwards. Oh, and end up at that spot. So it's 30 minus 360. And I have negative 330 degrees. In order to find the third one, I can keep subtracting 360, or I can add 360 to the one I had before. So I can have 30 plus 360 plus 360 again, and I end up with, what, 750 degrees. Sometimes the directions they ask you to find all angles that are coterminal with 30. Well, from the previous example, you can see that we're adding and subtracting 360 degrees. So the way I would write my answer is 30 degrees plus 360k. And k is any integer. Integers are positive and negative, so you get this. You get positive and negative angles this way. One of the main focuses of this whole chapter is knowing your unit circle in degrees and radians. You need to know that 30 degrees is pi over 6. Pi over 4 is 45 degrees. 90 degrees is pi over 2. Pi is 180. You need to convert quickly back and forth all the way around the circle, all 360 degrees. And that's something we're going to work on for the next few weeks. Arc length is given by the formula L equals R times theta. R is radius, theta, angle, in radians. That's important. It must be in radians to do arc length. An example is the second hand on a clock is 5 inches long. How far does the tip of the second hand travel in 45 seconds? So here's my clock. The second hand starts here at 12. It travels for 45 seconds, which brings it over here. We want to find that distance traveled in radians. If it went all the way around the circle, you'd have 2 pi radians. But it only went 3/4 of the way, or 45 out of 60. 45 seconds out of 60 seconds, which is 3/4. You multiply that, and it gives you 3 pi over 2 radians, the distance the angle that the hand traveled. Arc length, remember, is radius times angle. Our radius is 5 inches. Our angle is 3 pi over 2. And we end up with 15 pi over 2. And that's a good answer. We like to leave it exact. That would be in inches. Linear and angular speed. Linear speed deals with the distance traveled. Our good old formula, D equals RT, or R is equal to distance divided by time. On a circle, the distance traveled is the arc length, right? So here we are, the distance traveled is this way, that's arc length. Remember, arc length is R times theta. So linear speed is arc length divided by time, so you have R times theta over t. Angular speed is the angle divided by time, so it's just theta over t. So how many radians per second? Okay, degrees per second, but it's radians per second because it's angular and linear speed, and we deal with arc length. An example of using angular and linear speed is a circular mobile is above the baby's crib, and it makes 5 revolutions per second. The first question is what's the angular speed of each revolution? Well, angular speed is angle over time. The time here is 1 minute. How many radians did it do? Well, at 5 revolutions, and there's 2 pi radians per revolution, so you get 10 pi radians per minute. That's the angular speed. How fast is the toy that is 9 inches from the center moving? remember, speed is r times theta over time. Well, we just calculated theta over time, and they told us r is 9, so you have 9 times 10 pi, and you end up with 90 pi inches per minute.